I'm Jim Weirich. I'm the Chief Scientist for EdgeCase, and I am here to talk to you about writing solid Ruby code. But first, I have a disclaimer. This talk is not about solid SOLID. After I made this talk proposal many months ago, and as it was accepted, and as I was doing the work on the talk, I realized about 2 or 3 years ago, I did a talk called Writing Solid Ruby. Or Solid Ruby was the name of the talk, and now this talk is called Writing Solid Ruby Code. So this is not about the solid principles, single responsibility, open close, list cough interface segregation, or dependency inversion. This is not about this. So if you came here to hear about the solid principles, you might want to give your seat to someone in the back who's standing. Sorry to disappoint. This is about something entirely different. But I'm going to start with a question. Actually, I'm going to start by starting my timer. Since this is the first time for this particular talk, I have no idea how long it's going to run. So I want to carefully monitor how much time I have left. I'm going to start with a question. I want to ask you, how confident are you in the code that you write? In other words, if your manager came up to you and said, they're going to deploy the code tonight into production, and you knew it was coming up, you're ready for that, how well will you sleep at night knowing that your code is going into production overnight? Are you going to have your phone right there by your bedside just in case they call? Or are you going to sleep soundly? I hope you're sleeping soundly. But I know that I don't always do that, and I want to strive to have more confidence in my code that I write. So I thought, well, let's do a talk about how to do that. This is kind of inspired by some recent projects that we've taken on, some rescue projects, some other just inherited the code base from somewhere else. And it's a code base I'm not familiar with. I don't know. The tests weren't quite running everywhere, and we just didn't have a lot of confidence in the code. And I was wondering, how can we fix this? How can I get to a place where I am confident in the code base that I'm working with now? This is from the preface of the book, the Tech, the Program by Donald Knuth. You might have heard of Knuth, maybe. He was writing essentially an encyclopedia of all computer knowledge. And about, it was the second or third book into it, he decided that he didn't like the way books were typeset, and he took off like 10 years to write a typesetting system for technical books called Tech. He wrote the book, wrote the program, then he went back to writing his encyclopedia of software knowledge, so he's back to doing that again. In the preface to the book, he says, I believe that the final bug in Tech, his typesetting system, was discovered and removed on November 27, 1985. But if somehow an error still lurks in the code, I shall gladly pay a finder's fee of $20.48 to the first person who discovers it. And this is twice the previous amount. I plan to double it again in a year. You see, I am really confident. Wow. Now, being a programmer, you recognize that number, $20.48, as he probably paid a penny to the first bug, 2 cents to the second bug, 4 cents to the third, 8 cents, 16 cents. So this is, so we can calculate how many bugs he's found in his code, right? And that's what would be what? 10, yeah, 10 bugs. So he doesn't think there are 11 bugs, and he's willing to put money down on it, and he's willing to double it on that. So wow, that's impressive. I would love to get to be that confident in my code. So think about that question. Think about the level of confidence in your code. I'm going to do an aside for right now. I have found that in my programming career, there are a handful of books that I can just rattle off that have radically changed the way I develop code. And it has varied over the years from the very basics to more modern. And how many people can do that right now? How many people have read a programming book that really changed the way you develop? Okay, give me examples. Smalltalk best practices, I heard. Refactoring. The camel book, the pearl book, okay, yeah. Robust practices, the pragmatic programmer book, I heard someone say. Code complete. Oh, remember that one, because I'm not going to talk about it. I'm going to mention it, but we're not going to talk about it. Test-driven development, okay, very good. There are a handful of books, and here are the top 5 in my mind. The Pragmatic Programmer should be a footnote on this as well as a very early one I remember called Elements of Programming Style. Has anyone ever read that one? Yeah, Glenn has. Excellent book, yeah. That one probably should be up here as well, but that's a little bit older. But these are kind of 4 or 5 books that have really, really changed the way I develop programming. First one was Software Tools, and I got to tell you a little story about this one. I was a very new programmer, just out of college, maybe working in the industry for about a year or two. And I had a mentor named Sheldon Jordan. And Sheldon was wont to come by my cubicle and plop a book down on my desk and say, here, read this. And I remember reading a very early Grady Bush book on Ada at that time frame. And he dropped off this book one day called Software Tools. I said, okay, this is interesting. So I started reading this. It wasn't much later that Sheldon moved on to greener pastures and left the company I was working with, so we were kind of on our own. Someone was going through Sheldon's office, and he said, hey, there's a tape back here, and it's called RAT4. Now, we named all our programs at this particular job with 4-letter names and a number. So there was RAID 3, Trace without the E, 5, you know. So RAT4 was almost like one of our programs, but not quite, because it only had 3 letters and a number instead of 4 letters and a number. So they didn't know what to do with this tape. And they said, Jim, does this ring a bell with you? I said, RAT4. RAT4. What Software Tools is about is taking your programming environment and changing it to be good for you. These guys wrote in Fortran. And yes, I was doing Fortran at the time. By the way, that is a deep, dark secret that doesn't appear on my resume. So you were sealed to secrecy, okay? I was doing Fortran. How many people have done Fortran in here? Okay. Really wonderful modern language. Maybe not so much, especially when I was using it. What they did is they took Fortran and wrote a preprocessor that changed essentially what was C-like code and compiled it down into Fortran. They called the preprocessor Rational Fortran, or RAT4, R-A-T-F-O-R. The tape was labeled R-A-T, the number 4. So that's where RAT4 came from, Rational Fortran. And they go and then they develop all kinds of tools to use to help you program. They wrote essentially grep, not awk, but grep and some directory manipulation things. And that inspired me to take charge of my environment and start modifying it to work the way I wanted it to, despite the fact I was working on a huge mainframe machine that really didn't have a decent file system, and we were working in Fortran. And by using the ideas in that book really changed the way I approach software. I'm going to skip the next book, jump down here to Object-Oriented Software Construction. This one really opened my eyes on a lot of different things about object-oriented design. Bertrand Meyer is a brilliant guy. And I don't agree with everything he says in this book, but where I disagree, I always make sure I stop and think very carefully. Essentially, this book is all the reasons he developed his own language called Eiffel. Anybody program in Eiffel? Not very many. I actually was doing Eiffel on the side right before I picked up Ruby. I kind of stopped doing Eiffel and picked up Ruby right about the same time. But Eiffel's cool feature was a concept called design by contract, and where you specify the preconditions and postconditions of every method you write, and it's code. And when you generate the documentation for your library, it pulls out the method name, it pulls out all the arguments, and it pulls out the preconditions and postconditions for your library documentation. A well-written Eiffel library, it's a wonder to read its documentation because it's very clear and very succinct on exactly what that method does. Great programming idea. This is easily the most expensive book on this list. It's nearly $100, even today for paperback. Early 2000s, I put refactoring and extreme programming explained kind of together because this really changed the way I developed again. For the first time, I was excited about the process of doing software, not just about the writing software, but the process involved in it. And it really changed the ideas I had on that. I'm not going to go into that. We still talk about XP and test-driven stuff, so I'm not going to go deep into that today because I think that's kind of saturated. I want to go back and talk about this other book called Writing Solid Code. This book is, there's some interesting facts about this book that I want to share with you, okay? First of all, it's written by Microsoft Press. Yeah, I really was really clearing my throat. That had nothing to do with Microsoft. In fact, is there a glass of water back there, someone? I would really appreciate if someone could get me a glass of water. Back there? That would be awesome. I appreciate that. Written by Microsoft. And I'm not a big fan of Microsoft, but I'm also not a big hater. And it turns out that Microsoft is actually pretty good at finding good books to write. In fact, there are 2 books by Microsoft Press that are kind of forefront in my knowledge here. Oh, thank you very much. The other interesting thing is both of these books were written by Steve. One was Maquire and the other was McConnell. They were both published in 1993. And one, of course, is Writing Solid Code, which I'm going to talk to you about today. The other one was Code Complete. And it wasn't until I put these 2 pictures up here, I realized that the covers of both books are amazingly similar. The main difference between these 2 books are the number of pages. When he said Code Complete, he meant it. Writing Solid Code, in fact, I have it over here. Let me see if I can pull it out of my bag. Writing Solid Code is probably about 200 pages or so, quite digestible, very readable. And it was written by Steve Maquire. Here it is. Written by Steve Maquire. And it was inspired by the fact that when Maquire came to Microsoft, he came at a time when the development group was smaller, and the practices in place were really tuned towards writing good, solid code with few bugs. I don't know how he found that spot in Microsoft, but evidently there was this enclave right there. And he discovered that as new developers came on the team, that they were not adopting the habits that the original team had. And they were losing out on a lot of the knowledge that the original team had. And he decided to put together a book upon those practices and kind of call them out. And we're about 250 pages. That's what it is. So he put together a book, and there's 7 chapters. And the talk is going to be structured around these 7 chapters. As I was reading this book for the talk, I just lost my microphone. Thank you. As I was rereading this book for the talk today, I discovered that a lot of his specific advice just is not applicable to Ruby programmers. He was a C developer, and a lot of the things he wrote were specific to C because, man, if you're not careful in C, you can really dig yourself into a hole. So he has lots of advice on how to make sure your code is working correctly, how to make sure you don't have memory leaks, how to make sure when memory moves around, your program doesn't change. So a lot of the programming-specific stuff is a little out of date for this crowd. However, his general advice and his general attitude is really right on. So the talk today is going to be a little bit of his advice, a little bit of my advice, and a little bit of community advice that I got some feedback from some people. So let's go ahead and hit that. Let's start with Assert Yourself. Now, he makes a big deal about this in the book. And I remember when I was doing C, this is a big deal to me too, and adopting it really changed the way I did. What he's really talking about is if you're writing a method, you want to make sure that the program is working correctly. So they have these macros called assert that just asserts that something is true. And if you reach that point in the code and that condition is not true, the program dies, fails horribly. And that's a good thing in development. Because if you ever call memcopy and you have null pointers in there, you want to know about it because that is a bug and it must be fixed. The second assert is more about a relationship, make sure you're not overlapping memory copies there. That's a little bit different. But the key is that that is a macro, and when you compile it for production mode, that macro goes away and doesn't affect the performance of your code. So your code base in testing and in development have a lot of these consistency checks in them to make sure things work right. So, do asserts make sense in Ruby? And I'm going to claim not so much. First of all, let's kind of change this to a Ruby-ish kind of assert. And I made it a block so that possibly that in production mode you wouldn't even have to execute the block. But what are we doing? We're checking to see if something's nil. Ruby kind of does that for you. And if you let Ruby do the check, it'll give you a nice exception that tells you exactly where the error occurred and where it is. Now, you might not get it at the top of the routine, but it will eventually happen if it matters. So the assert not nil kind of tests are not nearly so important. And even if you comment that, or if you make it so you don't execute the block at runtime, you still got to build the block and you got to pass it in. You got to make a test to see if you're in production mode or not. So there's runtime overhead even in this assert version here. So let's say we do something more than just null checks. Let's say, well, okay, we don't have to check for null. Ruby does that, but checking to see if we got the right type of argument, that's still a good thing. I'm going to say not so much. If you put checks like this littered throughout your code, you've really limited the way that other people can use it. For example, here we're checking to make sure that this target object is a string. I wrote XML Builder, and it takes a string argument. But the only method I use on it is the double arrow insertion operator. So I don't really care if you give me a string or a file or anything else. You can even pass in an array, and that will still work. So explicit type checks inhibit the flexibility of Ruby in duck typing. And people say, okay, that's true. You want flexibility, that's what Ruby's good for. So you don't want to do explicit type checks, but maybe we can just check to see if it responds to the operator you want. I call this chicken typing. Because you're afraid to let Ruby do what it wants to do. So I'm not a big fan of chicken typing either. So asserts not so much, but let's go back to the principle, right? What is the principle behind putting assertions in your code base? Essentially, you're doing unit tests as the codes run. Now remember, this book was written back before XP became popular, before unit testing became the universal thing that everybody does, right? Everybody does, right? Sometimes we talk a lot about testing, but I'm not sure everybody actually does testing. But that's another topic. So what we put them in is to ensure program correctness, especially when we change and refactor, we want to make sure the code still works. So they are there to ensure correctness. We write tests. I was so excited I got to write this in like a 180-point font. Because I think this is important. The number one thing you can do to ensure correctness is to properly test your code with repeatable unit tests, with do TDD or BDD. That's the number one thing. If you're not doing that, at least write unit tests, write integration tests to make sure your entire system works, write functional tests that ensure your code does what the customer wants it to do. That's the difference between functional and integration tests. Who has heard of mutation testing? Yeah, I know you have. There's a wonderful Ruby library called Heckle, right? Yeah, Heckle. That goes into your code base and modifies your code and then runs a unit test. The theory being that if you can change your code and the tests still pass, then your code isn't well tested enough. So it goes in and it will change like constants to different constant values. It will invert the value of a if test to be an if not test. It will replace values with nil and see if it still works. And if your tests still pass, then your tests are not robust. Now, the problem with Heckle is that it will tell you one of two things. Either that you have poorly tested code, or well, if you pass heckle, in other words, any change you make breaks the code, that'll tell you that either A, you have well-tested code, or B, your code is so interdependent that everything breaks whenever you change one thing. One of those two things. So that's mutation testing. Fuzz testing is similar, but instead of changing code, you're changing data. You are, if you're like a web server and you're accepting outside web requests, you can't trust the data coming at you. So fuzz testing is taking that data and changing it kind of random ways and just hitting the server with all the wild and crazy variations that you can possibly think of. You know, extra long packets, too short packets, wrong size packets where the size of the packet and the actual data mismatch, all kinds of bad stuff. Throw it at your server and see if you can still survive. That's mutation testing, all good things to do. And if you want good, robust, solid code, this is number one. I've used 20 minutes of my talk, and if I stop now, you will go away a more confident programmer. I'm going to just say a couple more things about testing, because I don't want to dwell on this too long. Some testing advice. Number one, think of tests as specifications. Now, I know there's this whole RSpec movement that says, oh, we use RSpec, so we're writing specs, not tests. Well, maybe. Just merely using RSpec isn't enough to actually make you write specs instead of tests. You've changed the vocabulary, but unless you change the way you write those tests or specs, you haven't really accomplished much, except you're using a different library. The key thing is to think of them as specs, and what you want to do is think of two things. Do the specs cover the code in question? Do they cover all the necessary behaviors of that code? In other words, if I were to pick up that library, if I were to look at the spec has what I want to do in it and covers all those bases. Are they necessary? Do they cover the necessary aspects of the code? The second thing is, are they sufficient? Actually, I got those totally backwards. Sufficient means, do they cover everything in the code? Necessary means, does it only cover what's needed in the code? I find a lot of tests are unnecessary. They test things that you don't care about. Testing private methods, the number one thing. If I'm using your library, I don't care what your private methods are. And there doesn't need to be a specification for a private method. Now, the code has to behave, and that private method has to implement whatever the specification says, but I do not specify private methods at all. That's sufficient. Necessary means, do you cover everything? Or do I cover only the code? I get them mixed up, but they're there. Necessary and sufficient. Oh, garbage slide. I mentioned this book earlier, and I want to mention it again because design by contract is exactly that idea. What does your method need to run? That is the preconditions. What must be true after your code has run? That is the postconditions. And design by contract is the most clearest explanation of those concepts that I have ever seen. And this is the book to read to get on board with that. Okay, the other testing advice is I say make the specifications, or tests, as readable as you can possibly make them. And I've got a little self-serving advice here. I'm going to pimp one of my own libraries called RSpec Given. And just a little run-through of what it looks like. This is in RSpec, so we've got context just like RSpec, but we also have these given things. And in this particular test, this is a test from RSpec from the Gilded Rose Code kata, which is a kind of a simulated business logic type of kata where we got a lot of arbitrary business rules concerning items kept in inventory and how the quality of the item in inventory changes over time. So, given an initial quality of an item, given an initial must sell in so many days item, and given an item initialized with a name and those two other things, given all that, when I call update quality. The beauty of this is the code I am testing. I don't have to pour through before blocks. I don't have to pour through it blocks. I know exactly what I am specifying. And that's in the when block. The givens are all the things that are there that I assume are available for the testing. So given these things, when I do this, what comes next? Then. So these are nested contexts within this. So this is the outer context here. This is a nested context. So given those three items, and when I call update quality, when I have a look, here's another given. Given a normal item that is before the cell date, then this should be true. The quality should go down by 1. When I update the quality, it goes down by 1 for a normal item. There's the nested given. There's the then. Here's another context. And a look. This is interesting. Let me, back up. So I can give new givens in nested contexts, and I can override existing givens in a nested context, which means I can vary only the thing that changes. The only thing that changed between this test and that test is that the cell and date is different. So I can easily see what's different in the specs. I can easily see what the expected outcome is. The guys in the office love this. In fact, they tell me they won't do another project without this. In fact, thank you. Bit like Gherkin. Yeah, it's, the given when then idea came from Cucumber, but this is kind of just pure Ruby, no DSL-y type stuff, just pure Ruby and blocks. And actually, it's a really thin layer on top of our spec. The givens are essentially lets, and the then is essentially an it block, or a specify block, and the whens are before blocks. No, it's not much more than that. So it's just a little syntax coloring on top of that. I really like it. It makes the test very readable. But let's move on. I thought I was going to run short. I don't think I will. Fortify your subsystems. In Rails code, you have a lot of things that look like this. This is in an application that monitors my stuff. So I have a stuff controller. And in the show action on a stuff controller, I grab stuff from params. Now, where does params come from? A URL, yeah. So you typed in the URL. So it comes from there. And that 3 there is essentially turned into the params ID and passed in. But that's a URL. I can go into my browser and I can type any URL I want to into my browser. What if I typed a 45 instead of 3? And this came in, and all of a sudden, I'm now browsing other people's stuff. So what you really want to do is this. You want to scope your stuff finding to the current user. If 45 is not in the list of stuff that I have, then it will not show and you will get an error, and it will be displayed. So fortify your subsystems means be afraid of stuff from outside your software. Don't trust things coming from the outside. And that can be things like user input, like we saw here. URLs are essentially user input. The database, although you might be writing a Rails app that controls that database, there's nothing preventing someone else from going into that database and changing the code with a SQL statement, changing the data with a SQL statement, and making it invalid. So be aware, stuff coming in from the database is not entirely trusted either. That is a good source of cross-site scripting attacks by putting a little bit of JavaScript in something that's supposed to be displayed on a web page, comes in from the database, you trust it, you throw it up, and bam, you got problems. Other software. If you are writing your system in different subsystems that communicate with each other over a message bus or through a Redis queue or something else, don't trust the data coming in, because that data is very easily corrupted. It's outside your software. You have no control over it. So fortify your subsystem by checking the data very carefully that comes in. Just don't have much more to say about that except be aware of that. Think about that when you're handling data. Now, like I said, I'm not a big one for putting a lot of checks in my code, but when the data comes from outside, that's a different item. That's when you do your checking. Within your software, not so much. Stuff coming in, yeah, check it very carefully.
Jim?
Yeah?
Quick, I don't know if I'm allowed to ask questions, but do you ever
Actually, yes, if you want to ask questions, that's fine. Unless we're running out of time, I might speed you along.
Do you ever use the taint flag in your Ruby programs?
Taint is a big club, and I find it hard to control, and I generally don't use it. So I generally get by with it. It's a great idea. I'm just not sure how practical it is in the long run. Although Rails is kind of doing something like that today with its safe HTML strings, which I think is a good move. I don't know if you know, the new Rails, I think since Rails 3 or so, will mark strings, whether they're HTML safe or not, and escape them automatically unless you say, the string is safe to put out. So it really goes a long way to preventing scripting attacks. Steve Maquire recommends firing up a debugger and stepping through your code. How many people here use the Ruby debugger regularly? Okay. How many people feel the Ruby debugger is a tool of the devil? You know, I've never understood that. Now, I don't use the debugger that much, but when I need it, I really need it. And I encourage you, if you're a kind of anti-debugger, pick it up and start using it and give it a try. It works great with Ruby 1.9 today. I've got it set up so that in Emacs I can fire it up and then I get the split screen where I see my source code and the debugger commands in the bottom and the source on the top, and that works really, really nice. Don't use it all that often. Don't use it like he suggests. Steve says, run all your code through the debugger and watch it step. I feel that if I'm doing TDD, I've got a sense of that already. So I don't feel the need for debugging, but it is a tool to be used. I'll give you two pieces of advice. Ruby debugger is the one. However, sometimes your problem is not so much which logic steps I'm doing, but what is the state of my data right here. There's a wonderful library called pry that you require the pry library in your code. Wherever you want to see what's going on, you put in binding.pry, you run your test, and it'll pop you into an interactive IRB session. And you can query the state of all your objects. You can CD into other objects and query their internal state. You can get listings of methods. You can run shell scripts. You can do all kinds of wonderful things. And I'm no expert on pry, but even the little bit I know makes it worthwhile. I've started using pry to do data exploration in my running code, and it's a really easy thing to use. So those two things, I recommend you getting to know those two tools very well. The idea, though, is to know your code, know what's happening through your tests, through using pry, through using the debugger. Make sure you know what each line of code does and how it works. I thought this would be a really fun section to do. Candy machine interfaces. There's a story behind this. Steve says he got the name of this chapter because at their place of work, at Microsoft evidently, at least when he was there, they have free pop, but you have to pay for the candy. So you get to the candy machine here and you say, oh, I want this Twix bar here. It's $1.25. So he goes over to the numeric pad, and then instead of entering the 147, which is the number to select it, he already has the 125 number in his head, and he punches that in instead. And out pops a bag of chips. Jalapeno chips is what he called them, instead of your delicious Twix bar. Candy machine interfaces are APIs where it's too easy to do the wrong thing. How many people have run into those kinds of interfaces? Yeah. Now, I thought it'd be really fun to bring up some code and make fun of it and all that. But all of a sudden, I had a mental block, and I couldn't find a really, really, really good example of this. But I saw a number of people raise their hands, so find me afterwards, and I will update this with your examples. His examples are, of course, from Steve, which is full of bad interfaces. Getchar returns an int. Getchar returns an int. And it's important you know it returns an int because if you put the value in a character variable, when you hit the end of file, which is -1, instead of storing the -1 in the character variable, you store FF, hex, which is a valid ASCII character. So you lose the fact, you will never hit end of file if you store that in a character. Realloc is an interesting one. This little piece of code here using Realloc. Realloc takes an existing buffer you've malloced from the heap and resizes it. And it will return you a pointer to either the original buffer, if the buffer is already big enough, or to a new buffer if it needs to give you a new, bigger buffer. It will also, okay, so that's a description of that. What's the problem with this code? It's that third condition I was about to mention. I didn't want to give it away. Third condition, if you're out of memory, it returns nil. Null. I'm sorry, we're in C, null. So assuming that pbbuff is the only pointer to your existing buffer, if you're out of memory, you've wiped out the only pointer you ever had to that buffer, and you've leaked memory. What a horrible, horrible interface. Candy machine interfaces, yeah. Let's find some good Ruby instances of that to make fun of. That would be nice. I asked on Twitter what advice people had a day or two ago, and someone nailed it exactly. I also design my classes so they're easy to use right and hard to use wrong. That is the essence of avoiding candy machine interfaces. You expected Tom Cruise, didn't you? This is what happens when you put copyright safe for reuse on your search criteria. How many people think of risk when they're writing their code? A handful of people do. I would say most developers don't stop to consider the risk of getting their code right or wrong when they start writing it. And they just don't give it much thought. So, wouldn't it be nice to have a command line message like this? Actually, we do. How many people have used this Psychro? Am I saying that right? Okay, a couple of hands. What? Sorry? Psychro? Thank you. What this does is computes the McCabe cyclomatic complexity number for all the methods in your project. Now, what is this? It sounds really fancy. It's not that fancy. It's not that complicated. A number of years ago, I read this back in the 80s, so this is an old metric. Essentially, the research they did said, if we take, and this was done in Fortran programs, remember, don't mention that, and you look at the flow graph through the program, and here we see that we got step 0, step 1, then 2, 3, and 4, that's probably in an if branch. Then down here, then between 7 and 10, there's some kind of looping thing going on with a while loop exit from 7 down to 11. So what you do is count the number of loops in the flow graph of a method, and that is its cyclomatic complexity. So this would have a complexity of 2. Actually, 3, because you count the mainline. So essentially, it's the number of paths through the code base. So every method has at least 1. And if you have a loop, that adds another 1, make it 2. If you have an if statement, that's another 1 that you would add. Surprisingly, if then else still only adds 1, because there's 2 paths, whether it's if and skip or if and else. So, complexity of this method is 1, unless you get really particular, and the paper says you really need to count ors in conditions and add a count for that. So the basic McCabe complexity thing would be, oops, see, I told you I'd trip on these, is 1 if you just count the paths, but if you take the conditions, it'd be 2. Most tools give you the simple version, which is okay, which is good enough for the most part. So this has an if then else. This has a complexity of 2. This is from the Roman numeral calculator kata. This has a each loop here, and then a nested while loop in there. So you get 1 for the main line through, and then an additional 1 for each loop, so that has a complexity of 3. Okay, so you can run that program. I ran it on Rake and got these results. Standard Rake options, complexity of 27. That's pretty high, But that's the thing that handles each and every option you can pass into rake. So it's going to be high anyways. I could reduce that by maybe factoring out some of the if then else's in that method. But it's not surprising that one's high. The other one, define, is actually a package task, and yeah, that one's pretty complex too. That could probably be refactored. Pass, map, and string, yeah. That's a complex one. A lot of conditions. We're interpreting a format thing. So this is really good at picking out the more complex methods in your project. So I was thinking, let's run this on one of the projects I've worked on in the past that will remain anonymous. And if you go to a person working on that project, you ask them, what is the worst possible piece of code in this code base? And they will immediately tell you it is the dispatch controller. The number 79 there does not give you a feel for this. So here's a little terminal screen, and it's a really small font, not to protect the code, but to protect you. And this is just that one method. This is not the entire controller. This is the one method. Yeah, we wouldn't have enough. I should have played it in Ruby Gems singing. We wouldn't have enough time to listen to that song. We're hitting 40 minutes here, so I need to wrap this up pretty quick. Yeah, okay, there's the end. Okay. Whew. Not only is it long, it has little tidbits like this buried in it, where you have a return statement immediately followed by a def. WTF. This has got to be a copy and paste error, where they were defining a new method and put it in the wrong spot. It just happens to be a spot that never gets executed, so no one cares. Because right after that is the very next else if for this condition. Dispatch controller. I have a feeling everybody's running back to their projects now and saying, is that in mind? Do I have a dispatch controller? The scary thing is I've talked to other people in our office, and they say, oh, I've seen worse. Okay. Treacheries of the trade. Now, this photo actually isn't from Flickr. It's from my own personal library. I took this picture while in Scotland. This is up on the Isle of Skye, and our tour bus guide was taking us back to a little waterfall. And I ran into the side. I thought it was hilarious. Because what you understand, to reach this sign, you must walk this path. In order to get close enough to the sign to see what it says, it is too late. Wonderful, wonderful little waterfall. Just beautiful, beautiful area back there. So, risky code. What? Okay, when I ran across this, I said, what is going on here? Because I remember writing this method. But I don't remember leaving it like this. Evidently, when I wrote it in the when branches, I used a single trinary operator, single conditional operator that chose one of two things, and I felt that was straightforward. Whoever came in after me decided, oh, that's a good idea. Let's string them all together. And I talked to him and says, oh, C programmers do this all the time. And I go, hey, I'm not a C programmer. And this may be a styling issue, and some of you might be going, what's wrong with this? Other you guys are going, oh, okay. Yeah, nested conditional operator is not my favorite thing to see. I left it as is for the moment, but then later I had to come and add some stuff to this. I said, I can't add anything to this. This actually turned into a lookup table. Much easier to read, much easier to modify and to change. Yeah, scary stuff. Got to relate to you a little story here. Let's see what we're doing on time. Oh, you're laughing. You know this story. Yeah, we'll go through it quickly then. This is from Zed Shah. He wrote a blog post. In the blog post, he said, one of the things that's really great about agile languages is the great flexibility to give you the power to do anything. One of the bad things about agile languages is they give the same power to every other idiot to stab you in the back with a rusty pitchfork. He then goes on to relate a story about a logger, in which that standard Ruby logger is really, really nice if you haven't used it. It gives you all kinds of flexibility, the ability to change the formats and everything. Someone went in and hard-coded the format so you could not change it through this, monkey patched it to do so. He said not only does code reopen a class to do something, it could be done with subclassing. Sorry, I'm getting excited. But he turns off the documentation so no one knows that he does it. Not currently what we like to think about as the principle of least surprise. No, not at all. Then he found that other projects do the same thing. And he goes and he shows us the code. I'm going to skip over that kind of quickly because the comment the developer left in was this. Yeah, you think. The upside of this, don't use complicated solutions when simple ones will do. And I call complicated things like monkey patching, metaprogramming, and even alias method chain. If standard OO subclassing will do the job for you, or the logger gives you the ability to set the format in a standard way, use that. I can't tell you how many tests I've seen where they're testing two things and they decide to metaprogram the test. And they do it wrong. So don't be overly clever. Keep your simple solutions for simple problems. Only pull out the big guns like metaprogramming and monkey patching when you really, really need them. You know, I'm all for doing it, but do it when you need it, not just all the time. So, how do you instill these ideas into your developers? You have to have the right attitude. You have to go and approach the problem with, we are going to develop solid code, and we're going to set some principles. Talk to the other people in your group. Get them to decide on good programming practices and make that kind of standard in your development group. Encourage it. Bring on new people. Bring them in by pairing. Don't take a new person, put them off in the corner by themselves where they don't get feedback from the rest of the group. We have that problem with remote teams, that a remote person will come on. And we're all working in our office, and we're all sharing the good ideas, but that remote person is out there clueless about what's going on. And bring them in and help them get started, especially be sensitive to remote people. I think I am running out of time, so I'm going to go through the rest of these slides kind of quickly. Bugs just don't go away. Don't ignore bugs. Find out why the bug was there. Oh, I hate Heisenbugs. Don't fix bugs later, fix them now. And then write a unit test to cover the bug that you just found. There's a good story here. I'll tell the story quickly. There's a doctor standing on a fishing pier, and he hears someone out in the middle of the river, and he's drowning, calling for help. So the doctor swims out, pulls the fellow in, gives him mouth-to-mouth, resuscitates him, and just as he finishes, he hears two more people out in the river. So he jumps in, he drags those two people back, and he saves them. And as he saves them, then there's four people out in the river. He swims out there, and he drags all four people back. And then there's 8 people, and it just doesn't stop. What the doctor should not be doing is saving people. He should go upriver and figure out who's throwing the people in. Fix the cause, not the symptom. If you're fixing this, fixing that, go and find out the root cause of why these bugs are cropping up and fix them as well. Testing. The bottom line is your code is your responsibility. Take charge of it and do the right thing. Thank you very much.